This is an interesting question. Watch this video to the end. The question says a man with a mass of 80 kg slips down a pole. If the frictional force between the man and the pole is 720 Newton, calculate the sliding acceleration of the man. Take g, that is acceleration due to gravity, equal to 10 meters per second squared. This is an image or a picture representing what the question is saying. A man that is sliding down a pole. Looking at this image, we have the man sliding down and the mass of the man, according to the question, is 80 kg. So we can say the mass of the man pulling him down is equal to 80 kg. Again, there is a frictional force. Friction always opposes motion. So if the man is sliding down, it means the frictional force opposing it must be going upward. So we can say that the frictional force Fr equal to 720 Newton according to the question. The frictional force between the man and the pole is 720, and it must act in opposite direction to the weight of the man or the mass of the man, because the man is sliding down. The frictional force will be acting in opposite direction. According to the question, we have to calculate the sliding acceleration of the man. So the man is sliding down, which means there is still some amount of force pulling the man down, and we want to know the acceleration with which the man is coming downward. Of course, if the frictional force is equal to or greater than the weight of the man will stay there forever without sliding down unless there is an external force. But the question suggests that the man is sliding down, which means there is a difference between the weight of the man and the frictional force. That force pulling the man down, we don't know its value. So let's call the force F. We don't know it, and it is the force that is actually pulling the man down. Before we start solving, we want to know the equivalent weight of the man because we are given the mass. We need to calculate with the weight because weight is a force, and every other data in the question represents force. So the man's weight, let's call it W, is equals to mass times acceleration due to gravity, G. So that W is equals to 80, the mass of the man, times 10, the acceleration due to gravity, and that will be equal to 800 Newton. So that is the weight pulling the man down. If the weight is acting downward at 800 Newton and the frictional force is going upward at 720 Newton, definitely the balance of the force is acting downward, F. So we can say that F, the force pulling the man down, will definitely be the difference between the weight and the frictional force, W minus Fr. If we put the values, we have that the force pulling the man down is equals to 800 minus 720, and that is equal to 80 Newton. Now that we know the force that is pulling the man down, we can then find the acceleration, the sliding acceleration of the man. We know generally that force is equals to mass times acceleration. Since we are looking for acceleration A, let's make it subject of formula by dividing both sides by m, and that becomes A equals to F all over m. The force pulling the man down is 80. We've calculated it. 80 divided by the mass of the man is also 80 divided by 80, and that gives us 1 meters per second square as the answer. So the acceleration, the sliding acceleration of the man is actually 1 meters per second square. It is very, very simple, and I believe you enjoyed it. Now try this simple one. What is the coefficient of the sliding friction in this question? What is the coefficient of the sliding friction? As a hint, the frictional force is equals to the coefficient of sliding friction times the weight of the man. Please put your answer in the comment section, and thank you very much for watching this video. Hope to see you in the next video.